Today we are working with the slope-intercept form, or y equals mx plus b, which is the equation of a line. And what we're going to do is we are going to be given an equation, and from that equation we are going to graph a line. So we need to know, in slope-intercept form of y equals mx plus b, what does each of those letters represent? So when it comes to dealing with slope-intercept form, the most important letters to deal with are M and B. And of course, when we talk about letters, we're talking about the variables. So the M and the B are what we are going to be focusing on most. The M is the slope of the line. And remember, when you deal with the slope of a line, it must be in fraction form, rise over run. And we are also dealing with the B variable, which represents the y-intercept. And that is where the line that is being graphed crosses the y-axis. Now, let's look at a quick coordinate plane so we know exactly what we're talking about. So here's a coordinate plane. The line that runs straight up and down, that is your y-axis. And the y-intercept, or the b value, is where that line crosses the y-axis. So if the y-intercept is a positive 3, we will put that point on the positive 3 of the y-axis. If it's a negative 4, we'll put it on the negative 4 of the y-axis. But we will use only that y-intercept when it comes to starting our graph. And sometimes with my students, I call that the starting point. So the b value, the y-intercept, is going to be the starting point where we start graphing. So we will start from that point and then use the slope to find any other point that may be inside or in the line or along the line. But again, today we're dealing with slope-intercept form, y equals mx plus b. So let's look at a few examples of what I've been using in my class. So again, in my class, I repeat this over and over and over and over. Y equals mx plus b is the formula that you have. We're trying to find that the slope, so m is the slope, b is the y-intercept, and you may just see me write this over and over and over and over. But if you look at the equation that we have y equals 1/2 x plus 3. Well, the number that is in front of x, that is touching x, that is being multiplied into x, however you want to say it, that is our slope. So the slope is touching x. The number that is not touching x, that is being separated by x with an operation, you'll either see a plus or a minus, and more times than not, if it's set up in the y equals mx plus b form, it will always follow x. But in this case, we see that we have a plus 3. So that plus 3 represents our y-intercept of b. So in our y equals mx plus b form, we know that our slope is 1/2, or 1/2, and our y-intercept is positive 3, plus 3. So if you would happen to find that your intercept is minus 3, that minus just lets you know that the y-intercept is negative. So with this, we know our slope is 1/2. That just tells you that we will be traveling up 1, right 2, as you follow the line from the starting point, or the y-intercept. And the starting point is going to be 3 on the y-axis. So the y-intercept, your very first point, will always fall on the y-axis, and it's going to fall somewhere along that line. So since it's positive 3, our first point will go at positive 3 on the y-axis. Now, a mistake that my students seem to make is once they put that y-intercept, they want to use the slope starting from the origin. You do not start from the origin if your y-intercept is not 0. You always start from your y-intercept first, following the slope of the line. So what we have is y equals mx plus b. Our slope is 1 over 2, up 1, right 2. So from the line that we have, we are going to go up 1, because that's our rise, and our run is plus 2, so we go twice in the positive direction, and there is our next point. And from there, you only need 2 points in order to draw a line. 2 points do make a line. That's not a very straight line. Sometimes technology isn't always your friend, as it may seem in class. There we go, that's going to be close enough. And you want to put arrows at the end of your line so you know it goes on forever. So if you would happen to continue following your graph, because again, our y-intercept was here, and we went up 1, right 2, so up 1, right 2, and there was our next point. But if we continue to go up 1, right 2, you see that we're still on our line. Up 1, right 2, we're still on our line. So you can see all of the points that are on this line, and our linear equation, our slope-intercept form equation is y equals 1/2 x plus 3, and that was how we used the y-intercept and the slope to draw the line on the graph. So let's go to the next equation that we have. Again, y equals mx plus b. The m is our slope. The b is our y-intercept. So in this case, make these a little bit larger for you guys. We know that the slope is being multiplied into x, is touching x. In this case, it is negative 3 over 2. And the y-intercept is positive 1. That just tells us on the y-axis that our first point will be at plus 1, positive 1 on the y-axis. Now our slope is negative 3 over 2. The way I teach this is you have that negative, and you have to either choose to attach it to the top number or the bottom number. It doesn't matter which one you attach it to, you will still be able to draw the correct line. I always teach it as if you want to put the negative with the top number. That way you're always going right. And what I mean by that, so we're going to put the negative with the 3. So negative 3 over 2. This tells us that we are just going to be going down 3 units, right 2. So if it was positive, you'd be going up and right. If you're going negative, you'll be going down and right. Sometimes there's reasons that we can't go that direction, and we'll have to use the opposites. We may cross that bridge as we do this. But we do know with y equals negative 3 over 2x plus 1, our starting point will be positive 1. So we know that we're going down 3 units with this. So from our starting point, we'll go down 3 units, 1, 2, 3, and right 2, 1, 2. And there's our next point. And if we wanted to, we could continue on. Down 3, 1, change my pens, down 3, 1, 2, 3, right 2. And you can even see as we do this, the line is starting to be represented on the graph. And if you just would connect those points all the way across the graph, put our arrows, you would see that we have a negative sloped line when you travel from left to right with a starting point or a y-intercept of 1 with a slope of negative 3, 2. So with this, if you know that your slope is negative, you know that it's going to travel down from left to right. So if it goes up as you travel from left to right, you may have done something wrong. Just double check your work, double check your slope. Now here's another example of something that causes confusion in my class. Again, y equals mx plus b. M is your slope. B is your y-intercept. Now, I repeat this a lot in my class. That's why I'm repeating a lot right now. It's kind of a way of hammering it home for you. So again, we're still trying to find our slope. We're still trying to find our y-intercept. So in this case, we notice that something's missing. We realize that we do not have a b value. We do know that our slope is negative 4 over 3. That's not going to change. Negative 4 over 3. However, following x, where we usually would see our y-intercept, there is nothing. As I tell my students, if there is nothing there, you still have a number you can write down. What is the number that represents nothing? 0. So if there is nothing that follows x, that means your y-intercept is 0. So that would be the same as negative 4 over 3x plus 0. But in this case, we don't have a plus 0 there. We just have nothing, so the y-intercept will be 0. Meaning, this is the only time that the origin of a coordinate plane would be your starting point. Our starting point on the y-axis would be at 0, 0, or 0 on the y-axis with a value of 0. You know how it works. Now, looking at our slope, it's negative 4 over 3. So as I told you, I'm going to take that and make it, put the negative at top, negative 4 over 3. So that would mean that we're going down 4 and right 3. So if we would, from our graph, we go down 4, 1, 2, 3, 4, and right 3, 1, 2, 3. You can see that we have found our next point. However, let's just do this a little bit different. Let's say we use the same slope, but we're going to make it positive 4 over negative 3, meaning we will go up 4 and left 3, up 4 and left 3. So let's see what that does to our line. So starting at our y-intercept, we're going to go up 4, 1, 2, 3, 4, left 3, 1, 2, 3, and put a point. And when we draw our line through our first 2 points that we did, you'll see that it also goes to the point of the other way. So that's just showing you it does not matter where you put that negative in the negative 4 over 3. As long as you see that your slope goes down as you travel from left to right, you'll know that you have a negative slope. Positive slopes will go up as you travel from right to left. Now the last part that it really causes confusion at first for my students, we have x equals 1. Y equals mx plus b is our slope-intercept form. Yes, m is our slope. B is our y-intercept. But we know right off the bat, in this equation, there is no y value. So there is no y. It's not set up to y equals mx plus b. And whenever you have a situation where you don't have y equals mx plus b, or y on one side, x on the other, you know that you do not have a line that you can graph with a slope. This is an undefined line. So the slope of the line is undefined, so we have to draw a line that represents this right here, x equals 1. So whenever you get a problem when it has x equals a number, that tells you that the x value will always be that number. In this case, x equals 1. That tells you the x value will always be 1 and it will never change. Does not matter what y is, because x value will always be 1. So in this case, on our graph, we're not going to mark our y-intercept, we're actually going to mark our x-intercept because we know the value of x is 1. And the way we show that the value of x is always going to be 1, we're going to draw a vertical line on our graph showing us that the value of x equals 1. So if the value of x equals 1, you'll just do a vertical line because that's an undefined slope. So with this line, you can see that it'll be a vertical line that's straight up and down. Now also what you may see is in a situation where y equals 3. If y equals 3, there is no x. Well, you can draw a line without an x. Just know if there is no x value, there is no slope. So we know, all we have is the y-intercept value, so we know, let's use different colors. So our y-intercept will actually be positive 3, and since there is no slope, that means that the line is going to be flat. And as you can see, we have our second line. Let me make it gold. And our gold line we have the y-intercept of 3, and the equation of the line is y equals 3. So if you ever get to the point that you have x by itself, know that it's an undefined line, and you'll be drawing the line you'll be drawing a vertical line on the x-axis with the given number or value, And if you do not have an x value, you know you still draw a line that goes left to right. It's just not going to go up. It's not going to go down. It's not positive. It's just a flat line that goes left to right, crossing the y-intercept wherever it says y is equal to. Hopefully this helps. Hopefully you can use this information to finish up any work that you have involving this. And if you have any questions, feel free to ask.